So this is one of the most underrated and undernoticed things when it comes to machinery in the stone industry by everybody. And I mean the technicians, the sales guys, the guys that are right there talking about and commenting all over Facebook and all over social media about robustness and rigidity and all that stuff. Okay, there's just something that those they don't notice, that I learned through fixing all the machines and putting my hands on all the different brands of machinery. 5-axis CNCs, all the bridge saws, all the CNC routers. And what is that? Well, if you look at a 5-axis saw or a 5-axis saw jet, okay, and I'm just talking about bridge machines, why do guys feel reluctant to buy CNC 5-axis saws in general?
Because they're not rigid as 3-axis.
Because now miters are very popular, okay? So if you have a Chinese machine that has a cast iron bridge where the head goes like this and the blade plunges up and down, okay? Or, which has a cast iron bridge and then the whole carriage goes like this and the whole steel where the head comes up and down, it goes up and down with the whole Z-axis lead screw, the cylinders, the motor. It's almost pretty much like 800 pounds of weight going up and down like this when the blade comes down into the material. When you have a machine where the whole gantry rotates, the whole weight of the gantry with the carriage, we call it the X-axis carriage that goes across. It's holding the Z-slide, it's called, goes up and down. The part on a machine that holds the motor or the blade motor or the spindle or whatever, it's called the Z-slide, Z-axis. Okay, it goes up and down. When you cut a miter, the weight to cut that miter is perfect. There's nothing that's going to move that blade when it's cutting on a 45. So the feed rate for cutting Taj Mahal is pretty decent compared to a 5-axis CNC saw. Like, why? Because the little carriage that's hanging at the bottom of the tiny Z-slide that's on a tiny X-axis carriage on the bridge of one of those saws, the stress and the mechanics of holding that blade motor, which weighs about 200 pounds, and it goes to 45, the only thing holding that 45-degree motor in place is this little mounted bearing. It's called a mounted bearing. It's a $400 piece that's on one side, and then there's a servo motor holding a little shaft that's holding a plate where this big heavy motor is attached. That little motor right there, it's got what's called an electrical brake. The electrical brake is magnetic, which means that when there's an influx signal of voltage going to the brake, it creates magnetism and it goes and it keeps the motor from rotating. But the stress of cutting Taj Mahal or cutting a hard material, granite, 3cm, while the 5-axis blade is going across, makes the whole blade motor want to go like this. There's no way that you're going to move that blade up and down, because you got a 800-pound carriage like this on the bridge with the whole part that moves up and down all on one fixed Z-slide. That's one singular piece. It's impossible to move that blade and make it wobble. But the little 1.25-inch shaft on either side that's holding that motor plate that's thin, that's 3/8 holding a big blade motor on a 5-axis CNC saw, you're going to make it twist and move while you're cutting a hard material like Taj Mahal, or like porcelain, or a hard granite that's 3cm, like fancy brown. So they got to step cut it. So that's why people are like, they're watching a 5-axis CNC saw cut hard materials and they got to do step cutting and it's really slow each pass. They're like, shit, I could cut this manual on a bridge saw that's heavy duty. Okay? The same principle applies when you're talking about routing. So everybody's like, concrete. They're talking about concrete. They're talking about, does metal structure really matter when you're routing finger bitting? Of course it does. A 3-axis router, most designs, it's practically identical to the model that they were making and then they're still making for glass. But when you're doing glass CNCing, they're using suction cups that are made for glass. The first models were the concept. I did refurbed concepts. It's the same exact machine as the glass model. So the carriage on the concept It's made to do a super hyper fast tool change, because people look at the machine at the trade shows. You can't see it grind granite. They look at the tool change and they say, man, that is a fast machine. Oh my gosh, that machine is so fast. The tool change is 3% of the whole workday. The real time on the machine is when it's cutting glass or stone. So they took a glass CNC, they changed the spindle, beefed up the spindle, but not the mechanics, and they called it a stone CNC. Every design of a stone CNC today was taken from a glass machine. Well, when you're milling glass, glass is only 3/8 of an inch on average. That's the thickness that people work. That's for shower doors, shower enclosures. That's most of the glass that gets fabricated. Then you also have car windows. It's a little thinner, but it's float glass. Float glass is very soft before it gets tempered, because they cut it to size, they do the edge on it, then they put it through the tempering oven, which is basically a conveyor belt oven going through, and they heat up the glass and then it gets tempered. That's why when you hit it with a hammer, it breaks it to 1,000 pieces, because it got tempered. But before that, it's super soft, and it uses similar diamond tools. So now all of these machines that came from the glass industry and the 3-axis router, they adapted them little by little for stone. Little by little, they beefed up a little bit the carriage. But the thing is, where you'll see people mention this, the weight on the carriage, nobody talks about this. You see bridges that are gymongous. You see some CNC routers, you look at the gantry, you could fit a human, he could probably like crawl through comfortably the whole bridge, because it's so big, the bridge. But when you take the cover, the plastic cover off of the carriage on the CNC router, you see a router that's very lightweight. It's basically sheet metal that's like wrapped around the bridge. And it has a little baby motor for the X-axis. Why? Because in order to do that super impressive fast tool change, you have to have a lightweight carriage. Because if I move the T-Rex carriage at the speed that I move that thing, all the mechanics would wear out in the gearbox that has to stop on the drop of a dime, the gear, to hold back the momentum of all that weight. Because the T-Rex Z-slide is crazy. It's all steel. There's no aluminum. A lot of guys on 3-axis routers use aluminum plate so that it's lightweight. So they use 1.25" aluminum plate, sliced, milled, drilled, and they put the pieces together like a Lego, but it's all aluminum, so it's very lightweight. And you will see this on a lot of American brand machine CNC routers, even 5-axis saws that are on a bridge. So now the carriage is lightweight. Well, if the carriage is lightweight and they can do the fast tool change, they're impressing people, because we don't use calculators when we buy equipment, unfortunately. We go to trade shows or we go to a shop to visit and we see and we think that it's fast because the positioning speed's fast. But nobody's really calculating differences on when the blade's actually in the material cutting, or the finger bit's actually inside the material doing a sinkhole cutout. And so what ends up happening is that you get a machine that has all aluminum on the carriage. It's super lightweight. It's doing the fast tool change, but that favors the machine company, because the machine company doesn't have to spend a lot of money on heavy mechanics to move something heavy. Because if you have to move something heavy, the motors all across the machine have to be bigger. Well, if the motors are bigger, they're more expensive. Well, if the motors are bigger, then the gear racks and the mechanical system has to be thicker and bigger. Well, if that's bigger and the motors are bigger, then in the electrical panel, the servo drives have to also be bigger. And if the servo drives are bigger, then the contactors are bigger. And if the contactors are bigger, then the cabling is thicker. And if the cabling is thicker, it's more expensive.
It's all more expensive.
It's all more expensive. Understand? So now you have carriages on all the routers that are super lightweight. And to give you an idea, an average CNC router carriage on a 3-axis CNC from the most popular brands in the industry is no more than 800, 900 pounds.
How heavy is yours?
The T-Rex head with the spindle, that's 35 horsepower. That big spindle, how much do you think it weighs?
I don't know. Can I Facebook this part?
Sure.
The average, hold on.
Hold on, it's 300 pounds, but hold on. The whole fork of the head of the T-Rex.
We're going to get somewhere with this conversation.
Look, the whole
it's
fork
taking a while, though,
the whole fork head of the T-Rex, okay, with the spindle, is almost 900 pounds. Just the part that rotates.
Wow.
Okay. On average, they're 4 to 6 inches in diameter. The T-Rex is 13 inches.
Wow.
That's why the head, you can't crash it, you can't break it.
No, you
matter
can't.
how many
Even
times
if
you
you crash
bang
it, it doesn't break.
So you have the head only that rotates is the weight of the whole thing mounted on the bridge of everybody else's machine. The 5-axis and the 3-axis router.
I had a guy in the shop the other day, Joel from, he's in Lexington, and he just came for lunch. He was on his way to Alabama.
Oh, Joel Coleman?
Yeah, from Lexington.
Louisville.
Yeah, he stopped by. He was on his way.
Yeah.
So we were talking about routers, and he's like, "Man, why is your machine so quiet?" And I had him put his hand on the. There was no vibration, nothing. It's like, man, mine sounds like it's somebody's murdering those tools. Put your hand on the T-Rex. He's like, there's no vibration.
So basically, look, to give you an idea, the head of the T-Rex with the Z-slide, with the carriage, is 3 to 6 times the weight of every 3-axis router and 5-axis CNC. Period.
In the market.
On the market. Period. Because we don't care about the positioning speed going slower than everybody else. Because when I'm cutting,
you're cutting fast.
I'm 2 to 3, 4 times faster than everybody else
that
throughout the whole
plus.
day.
You're making it up plus.
Right. And I'm doing half the
cutting
number.
more
I'm
than
doing
your
half the number
tool
of tool
changing.
changes. Because I'm also double stacking the tool. Because I'm heavier, I can double stack the tools.
Yeah.
And everybody talks about flexion. Why does everybody talk about flexion? Because when they try to put 2 tools on one cone on a rinky-dink machine that has a carriage that's super lightweight with aluminum plate,
It can't handle it.
it's going to have deflection. Because the mechanics are weak and the motors are weak and the gearboxes and the mechanics are underbuilt. Because they want to do the fast tool change.
All right. I listen. So here's my response. Basically, the heavier the head, the more sturdy and less vibration.
Sweet and simple.
Creating the most accurate and fastest machine possible. I wonder who has the heaviest. Oh wait, hold on, what did I say? I wonder who has the heavier construction. Space, down, low, after you quit reading it, you see. T-Rex, in case you didn't know.
You sent this up.
No, I'm about to.
Oh.
Yes, it might be more expensive up front, but lasts way longer and way faster than anyone else, causing faster fabrication with less expense.
What you can say, I've had Poseidons since 2017, and I've never spent a penny on any mechanics, linear guides, gear racks, nothing. After crashing it, after working a full time. But that's the truth.